little bit about the class agenda. This particular class is a 3-module class, and tonight is module 1, and we're going through the introduction now. And we are going to be talking about really the big picture here, and that is going to be the air handling unit and chilled water system and how they fit together in a medium and small size commercial building specifically. And we're going to talk about building sizes in a few minutes here. In module 2, which is going to be tomorrow evening, we are going to get an overview of all the package chiller types. Then we're going to look at basic operation of reciprocating scroll and screw chillers today. And then in the third module, we're going to talk about components as well, I might add. We are going to talk about package chiller control. We're going to talk about typical operation and maintenance. And we are going to look at electrical schematics and start and run sequences for these package chillers. And we're also going to talk about some troubleshooting scenarios as well in that module. Now let's talk about commercial buildings. I love to talk about commercial buildings. And we need to understand something here when we're looking at the marketplace and when we are looking at our workload and what we're going to be doing and where we're going to be working. And that is commercial buildings today come in a lot of sizes and types, not just what people think. What many people think when you think of commercial buildings, this includes technicians, they're thinking about really large buildings. They're thinking about buildings on a college campus. They're thinking about hospitals. They're thinking about high schools. They're thinking about county government, city government type buildings, city hall, a courthouse, or a large building in a military base. And yeah, we're going to talk about those. That's going to be mainly the 403 class that we're going to be discussing those larger type commercial buildings. But interestingly enough, 75% of commercial buildings are actually 10,000 square feet or less. A significant percentage of these commercial buildings are 5,000 to 10,000 square feet. So they are relatively small or mid-sized commercial buildings. And these small and medium-sized commercial buildings, of which we're going to be talking about regarding these package chillers, have unique heating and cooling needs. And of course, the dependencies as well, depending on the application. So let's look at some examples of these. So I'm going to show one slide here regarding heat. We talked about these perimeter zones that may need some type of heat. And what I'm really trying to do here is give you some parts of the big picture puzzle on these buildings so that you can take a service call too hot or too cold and kind of know what you're dealing with here. But many of thase buildings, depending again on climate, are going to need some type of supplemental heat for these perimeter zones. And that could be provided by baseboard hot water heat, baseboard steam heat. So we're probably going to have a small boiler in these commercial buildings, these small commercial buildings again. We could have, if we've got variable air volume, which we will talk about in a few moments, we could have hot water reheat. And in some areas of the country, and I know that California, I've heard, doesn't like these, but some areas of the country like Florida and Georgia and some other ones, these are quite common. The Gulf Coast, electric reheat for VAV, and we'll see that a little bit. So don't discount that if you happen to be in a contract or a different part of the country where this is really frowned down on by code. So we may have to provide some heat. And in a small commercial building, that type of small package boiler is a very common situation that you're going to see in these small commercial buildings. Now let's talk about a VAV, variable air volume, a quote unquote typical VAV air handling unit. I call this the vanilla VAV air handling unit because it's a standard, typical, common type of air handler for VAV. But again, there are different, we have to understand there's always kind of like the oddball stuff that's out there. So what you see here is a central air handling unit. I'm thinking here, I've got some photos that really looks a lot like a photo of a school system that I worked in that had VAV. And they had about 4 of these air handlers in the building, 6 of these. I'm not remembering the exact number. And there were like 2 on the first floor, 2 on the second floor, 2 on the third floor, et cetera. So basically we've got an outside air inlet, and then we mix that outside air, fresh air, quote unquote, with return air coming back from the rooms. And then that central air handling unit is going to have a cooling coil, and then it will have a fan capacity control mechanism of some type, which today is going to be a variable frequency drive. So we can basically change the fan volume at that VAV air handling unit. And then that discharge air is going to go out to the different VAV terminal boxes, or quote unquote VAV boxes that we see here. You can see we've got our outdoor air inlet over in the lower right side. We've got a return air coming back. We've got our row of filters here. And then we've got our supply fan, and probably on the outside of the enclosure would be the VFD. And then we're going to have our cooling coil. Our cooling coil, and then our supply air outlet that will then discharge that air 55 degrees at a 1-inch static in the ductwork. Here is a little bit of a different drawing, but again, I'm trying to reinforce this because this is it's very important. Got my outside air coming in here, and then of course my return air coming back here. And then we call this the mixed air plenum. The mixed air plenum. And yes, indeed, for VAV, we do have 100% outdoor air VAV units, but we're not here tonight to discuss those. And then that mixed air, that mix of outside air, which could be economizer air as well, we need to recognize that, would then be brought across the heating and or cooling coil. And then we've got a variable frequency drive on the supply fan. And then we've got our discharge air that goes through the ductwork. And then what you see here are the VAV terminal boxes with the little sensors, or thermostats as they are called, that will open and close that damper. We're going to talk about those in a little more detail in a few moments. And then we're going to discharge that 55-degree air down into the rooms. We are going to have a sensor in the supply duct, usually 2/3 of the distance downstream of the fan, and it'll be in one of the longer supply runs, and that will sense the static pressure of the VAV air handling unit. I want to bring up one thing here before we move on, and we're going to move on here very quickly, and that is that we've also got a variable speed drive on a return fan. So the supply fan and return fan have a relationship of CFM, and that will then be used to determine the pressure in the building pressure.